Holy moly! All right, this is an answer video to Friday's work. So if you're okay with Friday's work, you can probably click past this, but if you had any struggle at all, I'm going to go through problem number 2, which was nobody had a problem with number 1 really. So I'm going to go through problem number 2 and then the bonus question just to kind of show you how that one worked. And so the first thing you want to do here is come up with the reaction. Without a balanced reaction, you're not in very good shape. So N2 plus O2, reversible reaction to get to 2 NO2. And so here's our reaction. I believe that is it. Okay, 2NO. Stupid me. All right, let me just erase that. Get the eraser going. First of all, I don't like that arrow. Second of all, I don't like that. Okay. Now, I apologize. Here we go. So we do have a coefficient 2 here. And now we're going to look at what our K situation is. It wants to know the equilibrium concentrations, and it gives us K. K for this is 1.2 times 10 to the negative 4. So can I approximate? So approximate question mark. The concentrations here are 1.00 molarity and 1.00 molarity. And that, so I have to have concentration over Q greater than 1,000. So 1 molarity over 1.2 times 10 to the negative 4. That, if I do that, equals 8,333. So yes, I can approximate. Yes, good stuff. Okay, next thing I'm going to do is what does my K equal? K is going to here equal, on the top, NO squared. On the bottom, concentration of N2 at equilibrium, concentration of O2 at equilibrium. All right, now I'm going to go to my ice chart. And in my ice chart, initial change and then equilibrium, N2 is going to start at 1.00 and it's going to be a minus X. So that's going to give me an equilibrium value of 1.00 minus X. But again, I can approximate, so I can get rid of that. On the O2, it's going to be the same thing. And many of the problems that I give you guys here are going to be like this, where you can do something other than use the quadratic, because you're working at home and I really don't like you doing quadratic. It's just, I want you to understand what's going on here. So here's the 2NO. It's starting at 0 and it is going to be plus 2x. So its equilibrium value here is 2x. All right, so now we've got our ice chart filled in. All right, so K equals this value. K is given in the question as 1.20 times 10 to the negative 4. And that is now equal to 2x squared over 1.00 minus x, 1.00 minus x. Now, the first thing I want to notice here is that because we can approximate on this question, I'm going to get rid of these. So they're not there anymore. And what I now have is this. I have 1.20 times 10 to the negative 4 is equal to 2x squared over 1.00, now that I've gotten rid of that, squared, because there's 2 of them, so they're times each other. Now, I can get rid of this squared, and this was where people, and I'm not going to name names, had problems. So now we're going to take the square root of everything, and when I do that, I have to take the square root of 1.2 times 10 to the negative 4 as well, and I get 0.01095. So what I have now here is 0.01095 is equal to 2x over 1.00. So let's just ignore the times 1.00. So what I have now is x is equal to 0.01095 over 2. And I end up with a final x value here equal to, what did I get? 0.00547. And that is my x value. So now this is going to be 2 times 0.00547, and that will equal what it says in the question, 0.011, just a tad around there. And that So that'll be our concentration. And these guys will both end up being 0.955 when we subtract out what that is. Don't do that yet. So where did I see mistakes or concerns with this? Mistakes or concerns in that things that the problem here, when you take the square off, you have to remember to square the k value. So you have to, square root of k. You have to take that square root of k, and that was sort of the issue, if you will, with some people. All right. Having said that, if you got to this point, you got this ice chart set up like this, and that you were excellent. You got the idea that you could approximate. That's why the question was provided. And that you came through this and forgot to square this, whatever. All right, whatever. We're going to get there before we're probably there right now. But you needed to make that mistake one time and stub your toe, and now you understand. Okay. In today's practice, make sure you don't do that. There's pretty straightforward practice today, but it is things where you can approximate. If you can't approximate, by the way, you do run headlong into the quadratic equation. And I guarantee, promise you, I will not give you a question on any test, quiz, or anywhere that involves a quadratic. I just don't like it. What I'd like you to understand more are things like this. With a k value of this, super, super low k value, that means that most of my substance is in the reactant. So this really, really favors the reactant. Things like that. Okay? All right, now I'm going to take a quick boo at the second one. This was the bonus problem, and I would just about move to tears with some of your answers. And that, by the way, not tears of frustration, tears of absolute something or other that you guys had this idea. So here's K. So K is equal to 0.15. Notice we have two solids in this guy. So they're not even going to come into this thing. So K effectively is equal to CO2 over 1. So the concentration of CO2, which means that 0.15, in order for this thing to get to equilibrium, has to be equal to the concentration of CO2. In other words, when the concentration of CO2 is 0.15, this thing is at equilibrium. Now, it says we've got a 100-gram chunk of solid calcium carbonate. So just like in previous times, we'll take that 100 grams of CaCO3, and this is what most of you did, 1 mole over 100 grams of CaCO3. And then it's you're going to make 1 mole of CO2 for every 1 mole of calcium carbonate that you throw into the thing. And what you came out with was 1 mole of CO2. It's a 10-liter vessel, so 1 mole of CO2 and 10 liters gives you a 0.10 molarity. This is so 0.10 is going to be less than 0.15, so it does not get to equilibrium. And that, my friends, was the answer. What is the level of this? This is a bonus question. If you got this thing right, you are probably approaching the Jedi level of this idea. And that if you got sort of here and then we're just kind of fizzled out, I'm with you. I understand. But it was about recognizing what things are not going to be in here and what get K actually have to equal for the reaction. And again, if you were thinking ice chart and you started to go down that avenue, and that you probably did not end up with a ton of success on this. I was really, again, excited. Anybody who got this correct, and that was fantastic. By the way, there was a word of the day, and that which I put in there, and that just for my own laughter, there is no, should we have a word of the day? Not everybody has to watch this because not everybody got everything wrong. So we'll go with that maybe on Tuesday. All right. Hope you're doing great. Talk to you later.